Okay, so we need a few reminders on working with fractions. I know you know how to do it. I just want to bring things to the front burner. So skill number 1 is writing equivalent fractions. So these are things that I know you know how to do. We're just refreshing. So I'm being positive. I'm going to remain positive. So writing equivalent fractions. All right, so let me think of a nice one here. 5 over 7 is equal to blank over 28. What goes in that blank? Anybody, anybody? This is good. It's good we're rehearsing. You said 20. How come?
Because you got 28 from taking from 4 times 7, so you have to do what you do to the bottom.
Yeah, and you said what I always say, the doo-doo rule. That's right. How does 7 become 28? Times by?
2.
Yep. So 5 times, whatever you do to the bottom, you better do to the top, right? So 5 times 4 is 20. That's right. So now here's the thing. Now we're claiming that 5 out of 7 is mathematically equivalent to 20 over 28. Now here's the thing. In the level before this, you were not allowed to use a calculator. We now are. So what could you do to be slick, to prove to yourself that you're right? Boy, I bet you could change 5 out of 7 to yep. And I bet you could change 20 out of 28 to a decimal. And they better be the same. So you could do that. Practice. Okay, so let's practice, like, see if we agree. So 5 out of 7, calculator is going to spit out a decimal, 0.714. 20 out of 28, if we did it right, bam, 0.714. And here's another mental check. Think about this. If 5 out of 7 people like the movie, is that a majority or a minority? That is a majority. If 20 out of 28 people like the movie, is it a majority? Yeah, because the halfway point would be 14, right? 50%. So yeah, it's a majority. So your gut instinct tells you that they're both majorities, right? And it turns out they're both like 71%, right? So whatever you come up with, you know you're right. All right, next level. This is everybody's favorite. Adding fractions that don't have the same denominator. All right. What if we had, I'm not going to even inject negatives in there right away. What if we had 5/8 and we wanted to add, let me think of a nice one here. Oh, 5/6. Okay, hopefully you're remembering something using the LCD, right? So when you add fractions, you have to use the LCD to write equivalent fractions. So first thing we want to do is we want to pick an LCD, the least common denominator. What do you think? 24. How come 24?
Oh no, just take it.
Okay.
Top of my head, I was like half paying attention.
Okay, so well, some people have what I call a good number sense, and they look at numbers and they see it and they feel it. What if that's not you? What could you do? Ah, I'm glad you said that. If you took 8 times 6, you would get 48, which is a common denominator, but it's not the least common denominator. So let's make a recipe. What if you wanted to get the LCD? What could be your recipe? Take the bigger number in the list, which is 8, and start taking multiples of it. 8, 16, 24, 32, and etc. Until you hit something that 6 goes into, right? So you agree that 24 is divisible by 6, right? So that's one way of doing it, is you could identify the LCD by taking multiples of the larger number until you hit something that they both go into. Otherwise, you could do what she said and just take 8 times 6 and get 48. So I want to mention this, CD, 48. 48 is a common denominator, but it's not the least common denominator. So the least common denominator is 24. If you use the wrong, you don't use the least common denominator, you get stuck reducing at the end. So let's use the LCD, which is 24, and write equivalent fractions, meaning 5 out of 8 is equivalent to blank out of 24. What do you think? I think I heard it. 15. If you're wondering how that happened, how does 8 become 24? Times by 3. So if I times the top by 3, I'm going to get 15. In other words, you could even write that here, times by 3, times by 3, the do-do rule. Or if you do to the bottom, you got to do the top. Okay, so how does 6 become 24? Yep, but if I times the bottom by 4, I'm going to times the top by 4, and I'm going to get 20. Yep. And then you can go ahead and add. So 15 plus 20 is? Aha, now the kicker. This is good for the online homework. 35 over 24. Should I leave it like that? No. Yes. Here's the weird thing. Last semester, they forced you to write a mixed number. Am I going to? Is the computer going to? If you wanted to write a mixed number, could you? And what would it be? You don't have to, but you could. What would you do? You'd literally divide and look for the remainder, right? So if you wanted to write a mixed number, you would say 1n. Yeah. So big note to self, not necessary. You don't have to do that anymore. The computer's going to want it like this. What is that? Yeah, it's improper. It's an improper fraction, but the computer's going to accept that. I did want to mention real quick a lovely skill here about the calculator. Since we're going to be using the calculator a lot, you want to know how to do fractions on your calculator, especially one like this. You would type in the original, let me page back there. You would type in the original fractions. Just make sure you use parentheses around it. So I have parenthesis 5 over 8 parenthesis plus parenthesis 5 over 6 parenthesis. Now here's the kicker. Calculator spits out a decimal. You get the calculator to send it back into fraction form for you. So you hit math, it says frac, you just hit enter, and hit enter. 35/24, that's what we got when we did it by hand. If you want to know how to do that on your own calculator, it'll take me like 30 seconds to show you after class. Okay. The very final thing, which I'm going to do on the calculator actually, is perform a reduction, because I want you to know how to manipulate the calculator to a certain extent. So let's see if I can do that here. Let's take sort of a hideous looking fraction, and yeah, we could reduce it by hand, but let's just practice using the calculator. So reduce 24 over 168. Well, yeah, we could do it by hand and using prime factorization, etc. I'm not going to go there right away. I just want to practice using the calculator for now. So I'm going to key in 24 over 168. Calculator spits out a decimal, but then I go math frac, and it puts it in reduced form for me. Yay! Takes 1/7. So 24 over 168 is 1/7 if you reduce. Now what you would really want to do is ask yourself, gee, how would I do that by hand? Okay, I'm going to hold